Hello everyone, welcome back to the channel and welcome back to a new feature. Today's spotlight is product feature. We're going to implement this feature as we have done in the other apps. As a side note, I could not actually come up with the solution, how to make pretty much what we have done under Kotlin. We have facing again the same problem as Swift. It has to be something, it has to be a solution somewhere, but I could not find it. Long story short, I could not find how to define a library within a library. I tried actually multiple combinations, creates WPF class library, creates WPF custom library, even a project. I always face the same problem when it comes to assembly stuff. And again, it has to be some solution somewhere. Therefore, in order to create a feature, it's going to be only a WPF user control library, if you will. With that being said, let's create under this solution a new project, a user control library. Let's call it product feature. Gonna make the data layer, domain layer, and presentation layer as folders. We don't have another choice. At least it is modular. All right, so let's click next, choose the framework and create. Delete this file, we don't need it. And let's create the dedicated folders for clean architecture. Inside the repository, we're going to create a new class. It's gonna be an interface, iProduct repository. From the three applications, we can infer the needed functions. We have to load the products and we have to paginate the product and get the suggestions as well as the list of products. It's worth mentioning that you can implement those methods using just async and await, but just for fun, let's create stream of data as we have done in Kotlin application and Swift application using a stream of data of type resource of the needed type. All right. First things first, before moving forward, I would like to set here the dependencies. Let's add the SVG library, SVG image, and another library for responsiveness. It's a grid extra, which is good. And here we're going to use the two libraries or the two dependencies that we have implemented earlier, core and core UI. This function is going to return an iObservable of type resource, type pagination response, of type product preview, gets products. And we need here the integer for the page. The next function is get products. It has to give us iObservable of type resource of type product by passing the product's ID, get suggested products, and search products. You know the drill by now. You have to implement the use cases. I'm going to implement just the first one and the rest is going to be provided because it's going to fall into the same category. It's going to be a public sealed class and we have to inject in constructor iProduct repository. And again with C#, we don't have the operator invoke. Therefore, we're going to make a public function. Let's call it invoke. That has pretty much the same parameter and the same definition of the use case. It has to return the repository and get products. We have to pass here as an argument the page. As simple as this. With the same manner, we can implement the others. Now we have to group all of those use cases for dependency injection purposes under a public sealed class. That's pretty much it for this domain layer. Now let's go to the repository and define the implementation. We need to inject basically the API service Pocket Goods database. This method has to give us a stream of data. Therefore, we have to construct the stream. We have to use the observable and we have to create the type should be resource. And let's add here the parameter observer. Let's create first of all the cancellation token. And the function that we are about to use has to do with some async calls. Therefore, we have to wrap this with a task and we have to use the task on run. We don't care actually about the result of this task. Let's do here run. This should be async. And we have to clean up basically using the disposable and create. Inside, we have to cancel the cancellation token. All right, now let's focus on what should be inside the run section. The whole thing can trigger or to raise an exception. Therefore, I have to wrap it with try catch. And we have to do here the API call. First of all, as I said before, it has to be a stream of data. Get the old cache. Next, we have to make the API call, cache the data, and return the new cache, basically. In other words, the single source of truth is basically the database. Let's try to look for this product detail using database, product entities, where product's ID equal the ID from the parameter. Next, we have to include all the information when it comes to the media, and we have to get the first or default async. Next, we have to send the old cache by doing onNext as an argument, a new resource of type loading, you guessed it, of type product, nullable, For the data, the product entity and to product. Now, if we have an exception, you have to send, all right, it has to be loading again, but it should be null. Now we just handled the cache of data. Next, we have to do the API call by adding here another try catch. Let's store this response under product DTO equal await and API and get. It shouldn't be null actually. The product is not found. It's going to throw API error 404. Therefore, it shouldn't be null here. It has to be non-null value. And for the URL, the same from Laravel. And let's convert the product DTO to product entity. Now we have to get the existing entity by doing variable. Let's store it here beforehand. Product entity, which is, it's going to be the same thing that we have done here. Comment this initially, database and product entities and add product entity. Save changes async. It is a very good idea here to add transaction. Before this try block, database, begin transaction. We have to commit async. Afterward, we have to emit some data to the observer by doing on next. And here we have to pass as an argument a new resource of type product. Let's serve the entity, product entity to products. At the end, we have to complete or to close the stream on completed. Let's say, for example, we have some kind of exception related to the database. For example, DB update exception, await, rollback asynchronously. And we have to throw an exception. It has to be of type API error. And if we have some generic exception, we have to roll back again. We have to send to the stream of data new resource of type error. And we have to pass the exception as an argument. Next, we have to finish the stream. And here we have to add the cancellation and token. As shown here, we have to pass the function as well as the cancellation token. And that's pretty much it for the implementation of the get products. We have to create the observer and we have to create the cancellation token and do run. First things first, we have to send to the stream of data a resource of type loading. It should be an empty pagination data. Make the API call by calling API service. We're going to store the response under pagination response DTO of type product preview DTO. And the raw get for the return type, it's product pagination response DTO of product preview DTO. And we have to pass the URL. Afterward, convert the data to pagination response. We have forgot actually to add here too. Let's come back to the implementation to pagination response. And for the mapper, let's call this parameter DTO to product preview. Next, we're going to send the resource of type success to the stream of data. And we have to end the stream by doing observer on complete. If you have an exception, we're going to end the stream as well and send the resource of type error to the stream. Let's implement the other function, which is get suggested products. Pretty much the same thing. First things first, we have to send to the stream of data a resource of type loading, empty array. Next, we have to make the API call. Now for the form data, we have to do data, and we have to pass here an object. Let's do new. For the key, it's going to be search query. Now we have to send and end the stream resource of type success. If we have an exception on next and we have to send an error, passing the exception as an argument and end the stream. I think that's pretty much it for this implementation. I'm going to fold those two methods, one last method to go, which is search products with the same manner, nothing substantial. With the same manner, going to construct the stream and make the API call and feed the stream of data with the necessary resource type. I think it's self-explanatory at this point. And it's going to be it for the implementation of this repository. All those methods are going to provide a stream of data. Now let's define the dependency injection module. It's going to be a public class. Let's call it product feature domain module. You can make it as sealed class if you will. It has to implement the IDI module. Now we have to provide the use cases, static function that's going to return product use cases. We have to define as a parameter iService provider, type provider. Let's name it provider. Now we have to get the repository, product repository, equal provider, and we have to get or to call the function get required service, which is the iProduct repository like this. Now we have the products. You can see here the resemblance between this library and Swingex. Return new product repository, and you have to fill in the blanks. Now we got the use cases. We have to register the implementation and the use cases. Let's register first of all the use cases by doing app container shared. It's going to be a transient. Let's use here the provider parameter, product use cases, and you have to pass as an argument the provider. We can do this. All right, this is a good proposition again by Visual Studio, which is more readable. You have to register the implementation first. The order here is very important. You have to register the repository, then register the use case. If you do the other way, it's not going to be able to provide this particular service. With that being said, let's use shared and register as singleton interface to its implementation. And we're going to come back to this particular product feature module in order to register the view model, which is very important. I'm going to add it here as a to-do in order not to forget about it. I think this is the only difference between this library and Swinject. Of course, it makes sense because under Swinject, we haven't showed Swinject how to inject the view model because we have used, if you do remember, the environment object and the state object to define the needed dependencies and to provide the needed dependencies. That's all for the data layer and domain layer. Now it's time for testing. Therefore, we have to create a new project. As we have done earlier, let's call it features test. Without command line, let's add a new project, type xunit and choose xunit test project. Hit next. Let's name it features tests. It has to be under pocket goods. Hit next and create. I'm gonna delete this and let's add the needed libraries for this test project. We have to install Fluent Assertion and the entity framework, NuGet package, install Fluent Assertions, entity framework core. Now we have to add the product feature to the test. Click on feature test. Let's add the project reference product feature. Now save the file. Under this product feature, add a new folder, a dedicated folder for all test cases for product feature. Now let's create under use case a new class. Let's call it product use cases tests. In order not to repeat the same pattern over and over again, I'm going to create a reusable class. I'm going to call it integration tests. This is just a personal preference. Inside the base, I'm going to create a new class. I'm going to call it integration tests. Should be public. We need the dependencies, the API service, crypto, database, and the SQLite connection. This is basically an error. We have to do here Windows. All right, let's come back to the integration test. It should be available right now. As an argument, we're going to pass the output helper for debugging purposes. itest output helper. Now we need to open the connection and to configure SQLite. Therefore, we have to create here the connection, SQLite connection, and let's add the output helper. Next, we have to provide the API service by doing API service equal new API service builder. Set the base URL. It should be a mock client, API mock client factory, and create. And we have to pass here the logger to log the messages. We're going to use this output helper to log the messages. Public void log the output test helper, right line, and pass the message as an argument, which is very simple. Now it has to be log. Let's do with the logger and build. For the crypto service, it's going to be very simple. Mock crypto service. And let's assign finally the output to output helper. Now for the cleanup, first of all, we have to ensure deleted for the database, dispose the context, and dispose the connection. That's all for this particular class. Now let's come back to the product use cases, and it should inherit from the integration tests. Now let's create the constructor output helper output base output. All right. I'm going to create here the private member that's going to be tested. Product use cases. We can construct the repository iProducts repository equal new product repository implementation for the API service from the parent and the database from the parent. We have called it context. Now we can construct the use cases. Now let's run the first test. We need to make sure that get products should return success when list of products previews. Now we have to arrange the page and we have to act and we have to call do to observe the states or the emitted values. Let's use the parameter resource. Afterward, we have to finish for the completion by doing last or default async. Now we have to observe the changes. Let's store the changes under a list. Let's call it result. It should be of type resource of pagination response of products preview. Now, if the resource is not null, we have to add basically the data. Now we can assert on the collection results. First of all, let's take the first value. Let's store it under loading by calling result of type resource, of type paginated response, and of type products preview, of type loading. Let's take the first one, first or default. All right. Now we need to make sure that the state is not null by doing loading and should not be null. Next, we have to make sure that the data must be empty. We have to arrange actually here the correct product from the mock data. Now we are expecting a success. We have to look for this under the results, and we are expecting only one snapshot. Therefore, we have to do first or default. For this assertion, we have to make sure that the success state is not null and the data not empty. And for the final assertion, we have to make sure that the data from the success and the correct data are equivalent. Under this particular scenario, we don't expect any errors. Let's try to assert that we don't have any errors by doing var error. With the same manner, we have to get it from the results and of type error and first or default. We need to make sure that this error is null. All right, that's pretty much it for this test. Let's run the test, and I can see here some errors already. What's going on? I think that we have to make it public. All right, now let's run the test. Right click and run tests. And the test passed, which is good. Let's see the output. You can see here the method that we have called using the logger. This is the logger that we have implemented earlier. This is the status code, and this is all the response that we have done in the mock data. And basically the stream is working perfectly fine. Now we have to check that the getProduct use case should return the correct cache product detail. First things first, let's arrange the correct product detail, and let's arrange the results where to store the observed data. Now we have to act, and we have to call here resource. We're going to wait, last or default. I'm gonna copy this. Now it's time for the assertion. First of all, we have to make sure that we are under loading state. For our case, we want to make sure that we can serve some data from the database during loading. Let's seed the data before acting, or let's do seed user data. Now we have to make sure that the loading data, let's just make a simple assertion here. We don't care actually about if it's correct or not correct. It should not be null. Next, we have to make sure that we are under a success state. Inside the success state, we have to check if the success is not null and the data is not null, and we have the correct product. And for the error, let's make sure we don't have any error as we have done earlier. That's pretty much it for this test. Let's run the test. And the test failed. Let's see where is the mistake. It is under this particular section. So the data is null. All right, this test is completely wrong actually. Why, you may ask? Because here under the implementation, we cannot actually load the data right here if it's not already cached. Let's say, for example, this is the first time you are running the application and there is no cached data. This is gonna always return null. Now for the assertion, or basically what should happen here is after calling the function getProduct, after saving, because here we have to save the data. Where? Yeah. Here we have to save the data. What I mean with that is under the test, use cases test, we shouldn't make here the assertion not null. It should be here null. And to make sure that we have the data under the database, we need to make the assertion right here after the success to check if we have the correct data from the database. Therefore, I will try to get the product entity as we have done here. I'm gonna copy this, gonna paste it here, all right? Instead of database, we have to use context. For the ID, it's gonna be product or correct product and ID. Now for the assertion, we need to make sure that the product entity is not null and it matches the saved data. Instead of this, we have to do product entity to product. They have to be equivalent. I think it's the correct assertion. Let's run the test. If it passes, it means that we can successfully cache the data. And it failed. Let's see where. Basically, the success state is null. Uncomment this particular section. Now we're not going to check anything that has to do with success state, just to see what kind of error are we facing. Let's run the test. Now, as I said before, it has to fail because we are expecting here an error. Cannot be tracked because another instance of ID. All right, I know what's going on here. Let's uncomment this section and let's come back to the implementation. This is why it's very good to run tests. Now, the source of the problem here is we are tracking basically the product entities. We need to remove the products from memory and to re-add the products to the memory. All right, that's basically the problem, as simple as this. Now, I was skeptical actually at first. I thought that the onConflict strategy is going to solve the problem, but it didn't. Uncomment this section, and we have to check if the existing entity is not null, which means that it is tracked under the database. In this case, we're going to remove the products entity. First of all, let's remove the related images by doing existing entity and images entity, by using database, images entities, and remove range and media. Next, we have to remove entirely the product database and products, existing products. Next, we have to add the products and the related images. I'm going to copy it from here, from the mock data. And instead of product detail, it has to be product DTO. Same thing, database and product DTO. Now it should work. Let's come back to the test. I'm going to copy the same query from here. Here it should be context. Now we have to make sure that this existing, or let's call it cached product, preferably for the first assertion, we need to make sure that the cached product is not null. And we have to convert the cached product to product model, and it should be equivalent. Basically, I'm going to copy this. All right, let's run the test. And the test passed, which means that we are able to cache the data, and the data that we are going to cache matches the correct one from the API call, which is good. Now let's move on. Now let's check the other way. When we will provide a non-existing ID, it should give us no product actually. Let's arrange the product ID and let's act as we have done earlier. Let's say, for example, product ID equal -999, something like this. For the assertion, we need to make sure that we are under the loading state, and we need to make sure that we have an error. And we have to make sure again that we have no success state. That's pretty much it. Let's run the test. And the test passed, which is good. Now for the other cases, get suggested products use case should give suggested products. As usual, we're going to arrange the query where to store the observed states and the correct suggestions from calling mock data and suggested products. Next, we're going to act. For the assertion, we have to make sure that we are under the loading state and we have no errors. And we have to make sure that we are under the success state and the list is not empty and the list matches the correct suggestions. That's pretty much it. Let's run the test. And the test passed, which is great. Now you have to test the get suggested products should give no suggestions when passing random non-existing product title. As usual, we're going to arrange some random query and we're going to do basically the same thing that we have done here. Instead of not empty, it should be empty. Be not empty, and for the rest, it's the same. Now let's run the test. Good, test passed. We have one last use case, which is search products should give non-empty products matching the search query. Let's arrange the query as well as the page and where to store the observed states. And now we have to act by calling the use case. Now for the assertion, we have to make sure that we are under loading state and we have no errors. And let's arrange the correct data. Now we have to make sure that we are under success state. The data should not be empty. Last, we have to make sure that the lists are identical. Let's run the test. And the test passed, which is good. Now for the other way, we're going to provide some non-existing query or some non-existing product title. We have to get empty lists. It's going to be similar. Instead of asserting that the list is not empty, we have to make sure that the list is empty. That's pretty much it. Let's run the test. It's going to be the last test under this products repository implementation. And the test passed. Let's try to run all tests to check for interference. Right click and run. very good, no interference, and so far so good. And that's gonna wrap up our today's video. We have learned right now how to make the integration tests. For the next video, we're going to implement the presentation layer. I hope you have learned something new. See you in the next one, and happy coding!